Okay, here's another example. Again, we're looking at different scenarios in getting all of the trig functions, but this is all centered around the unit circle and how to navigate the unit circle in a lot of different ways to get the information that we need. So in this pair of examples, this time you're being given not the angle, not the coordinates at the point of an angle, but you're given actually the trig function of an angle instead. And from this one trig function, you have to get the values of the other five. So let's take a look at that. So we're determining, exact values again. So we're going to leave everything as a fraction. So given that sine theta equals negative 15/17, and theta is in quadrant 4, determine all the other trig functions. Now, with this one, because we were given sine theta, we don't need to figure that one out. It's already been given to us. So we do have to figure out the other five. All right. Now, let's, take a look at where we're at. All right. So when we think of a coordinate of theta on the unit circle, right? That is usually an xy coordinate. But on the unit circle, the xy coordinate can take this form of cosine theta sine theta, right? A value of x and a value of y. Now, what we're given here is that sine theta is negative 15/17. So that means that what we've got here is cosine theta negative 15/17, right? Sine theta is equal to that. That at least is the y value. Now, where is the y value negative in the unit circle? Well, if we look at the unit circle, we have positive x, positive y, negative y. And so the quadrants where y is negative is here in quadrant 3 and quadrant 4. Now, we are told, to help us narrow that down, that our angle is in quadrant 4. So what's happening is we're somewhere down here where the terminal side is in quadrant 4, and this is our point. So here's kind of what our angle theta looks like. It goes all the way around, and its terminal side is right there in quadrant 4. And let me erase that. And so what we've got for the coordinates of this point is cosine theta negative 15/17. That's the coordinates of this point right there. All right. So that's kind of what we're looking at. Let's go ahead and make just quadrant 4 a little bit bigger. So it'll be a little bit easier to work with. All right, so here's quadrant 3. Here's quadrant 4. Theta goes all the way around and stops somewhere over here in quadrant 4. All right, and we already said that this is going to be cosine theta negative 15/17. Now remember that the terminal side of our angle theta, that forms the hypotenuse of a right triangle, right? And this angle right here, this is our reference angle. So when we think in terms of our reference angle, and from our reference angle, this side is the opposite side, And of course, this side is the hypotenuse. Think about the definition of sine. Sine is opposite over hypotenuse. Well, we also know that sine, in this case, is negative 15 over 17. And what that in turn means is that the length of the opposite side is 15, and the length of the hypotenuse is 17. So we know that the opposite side is 15, and the length of the hypotenuse is 17. Now, in order to get cosine theta is the adjacent side over the hypotenuse. Well, which side is adjacent to this reference angle? This is our adjacent side from here to here. That is the adjacent side. So how can we find it? We already know that the hypotenuse is 17. What we need is this adjacent side. Well, what we have here is we've got a right triangle. So let me kind of maybe take this right triangle and draw it down here. Let me do that a little bit better. So here's our right triangle. Try and draw it maybe in the same orientation. So we've got 17, 15, and this side is unknown. That's our adjacent side. Well, we need to use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So we have a, this is b, and c is the hypotenuse. So we have a squared plus 15 squared is equal to 17 squared. This will leave us with subtracting 15 squared from both sides. We're going to have a squared is equal to 17 squared minus 15 squared. Take the square root of both sides, and this will give us a value of a, which is 8. All right, so we maybe use a different color here. Yeah, I'm sure that'll work. Okay, so this adjacent side is actually a value of 8. So now let's calculate tangent theta. So, if you think about SOHCAHTOA, which is what I've been doing, okay, let me draw this a little bit better. Tangent is opposite over adjacent. And so the length of the opposite side was 15, and the length of the adjacent side, we just found out was 8. So that's tangent theta. And now let's look at the reciprocal of sine. The reciprocal of sine is cosecant. And that's just going to be the flip side. So the flip of numerator and denominator. Negative 17 over 15. The reciprocal of cosine is going to be secant. We just flip numerator and denominator. Now, there's one thing that I did not mention that I should have, and I don't want to get any further before I do. When I calculated this value of cosine theta and I got 8 over 17, I need to double check what the sine of that was, right? Because, over here in quadrant 4, the value of x is positive. So cosine theta would be positive. If if our angle had been in quadrant 3, then cosine theta would have been a negative value, a negative number. So, I put a positive here, which is correct. Okay. Um, and you'd also have to think about tangent, which I did not think of. Yeah, so that's 15 over 17, but the value of sine actually was negative, and the value of cosine was positive. So actually, I'm correcting a mistake here. So yeah, this should have been a negative 15 over 8. So yeah, it always helps to retrace your steps because I just realized I was almost made a mistake. So here, cotangent theta is going to be equal to the reciprocal of that. So that's still going to be negative, but it's going to be 8 over 15, like that. Okay. So, when figuring out, these other trig functions, you really have to make sure that you're putting everything in the context of the quadrant that you're in, and whether you're dealing with, positive values of x or positive or negative values of y. All right. Yep, that's right. All right. So here is a think, pair, share. So try to do this one on your own and resume the video if you need an explanation. Go ahead and give it a try. All right, we're back. So here we're given the tangent of our angle theta is equal to negative 20 over 21. And our angle is in quadrant 2. Determine all of the other trig functions. So we already have tangent, so we really don't have to worry about that. And so let's go ahead and maybe look at quadrant 2 and see what we got going on here. So here is our unit circle coming over and around. And here is where theta is going to be. That's its terminal side. Right here in quadrant 2, we have positive values of y and negative values of x here in quadrant 2. Now, if we remember SOHCAHTOA, we know that tangent is equal to opposite over adjacent. So let's go ahead and make our right triangle here. And this angle is our reference angle. And so the coordinates of this point are going to be relative to this reference angle. So the side opposite this angle, okay, that is our opposite side, and the side adjacent to it, that is our adjacent side. And so what we're told here is that this is a negative 20 over 21. So the opposite side is 20, and the adjacent side is 21. So the opposite side is 20, And the adjacent side is 21. Now I'm going to put a negative there just to help me remember. Okay. So the side that we're missing is we're missing the hypotenuse. And we need the hypotenuse so we can get sine and cosine later. So for this, we're going to use the Pythagorean theorem, which is going to be, instead of a and b, I'm going to use x and y. So we're going to have x squared plus y squared. And then this terminal side is our radius. So I will just use r squared for that. And let's see here, x will be negative 21 squared plus 20 squared equals r squared. Take the square root of both sides. And here r is going to be equal to 29. That is our hypotenuse. All right. So we need to come up with sine of our angle, which is in quadrant 2. Okay, and another way of writing sine, let's see here. So let's just put opposite over hypotenuse. Okay, and the opposite side is actually y over r. And our value of y is 20, and our radius is 29. So sine is going to be 20 over 29. All right, let's do cosine. So that's going to be adjacent over hypotenuse, which is going to be x over r. And the reason why I'm now using x is because I don't want to make the same mistake I made before. And I want to make sure that I put negative 21 in and put 29 there to make sure I don't miss that negative. Okay, and tangent theta, we already had. All right, now we need the reciprocals. So the reciprocal of sine theta is cosecant. And we can just flip numerator and denominator. Cosine, the reciprocal is secant, and we need to keep the negative, but we flip numerator and denominator. And then tangent, keep the negative, and just flip numerator and denominator. Oops, tangent. Cotangent. Sorry, cotangent is the reciprocal of tangent. Okay. So in this case, we needed to actually look at the right triangle inside the unit circle and think of our trig functions as values of x and y within that right triangle and use the Pythagorean theorem to get the missing side in order to fulfill the definitions of all of the other trig functions. All right, let me know if you have any questions.